So we have looked at factoring a GCF out of a polynomial, and then we've looked at a few days of factoring trinomials. GCF factoring can go with any polynomial. So one thing we're going to try to do today is we're going to start seeing some problems where there's a GCF and a trinomial that we have to factor. You should always, starting now, you should get in the habit of looking for a GCF when you look at a polynomial. There will not always be one, but you need to look for it, okay? So here I've got 3n squared minus 21n plus 30. So I'm going to look at this and I'm going to ask, is there anything in common to all three terms? What do you notice? 3 divides all of these, right? So we could do the ladder, or some of you are doing it without the ladder, you're doing it mentally, that is okay. But let me show it just to show those that still use the ladder. We're going to divide by 3. We get n squared minus 7n plus 10, and we end up with 3 times n squared minus 7n plus 10. Now when we learned how to take out a GCF or factor a GCF, we were done at this point. But now we know how to factor trinomials, so we need to look at this and see if we can factor it. So this 3 stays with us. We cannot lose the 3. It is part of the original problem and part of the answer. This is a trinomial, which most of the time factors into 2 binomials. I look at the last term, it's positive, that means my signs match. The middle term's negative, that means they're both negative. My first term, n squared, is n times n, and then I need factors of 10 that add up to 7. What would that be? 5 and 2, right? 5 times 2 is 10. Negative 5 plus negative 2 is negative 7. So if we were to re-multiply this, we would multiply this first, and we'd get n squared minus 7n plus 10. We'd get this part. Then we would distribute that 3, and we'd get what we started with. So the only difference on these problems is there will be a number that we can factor out before we factor the trinomial. Let's look at another one. 5n squared minus 10n minus 40. Is there a common factor to all 3 of these? 5 goes into all 3, right? So we're going to factor a 5 out. We're going to divide. We get n squared minus 2n minus 8. Is that right? And we end up with 5 times, we cannot lose that 5, n squared minus 2n minus 8. Never lose that common factor because it's part of this polynomial. We need it. So now we have the 5, and we're going to factor the polynomial into 2 binomials. We know we're going to have n and n. Our product, our last term, is negative, which means our signs are different. So we need factors of 8 that have different signs, and when we combine them, we get 2. So what is that going to be? What about negative 4 and positive 2? Does that work? N times n is n squared. Negative 4n plus 2n is negative 2n, and negative 4 times 2 is negative 8. I think that works. So there's our final answer. So we will not have a GCF on every problem, but you need to at least scan when you see a polynomial and ask yourself, is there a GCF I can factor out?